Hello, everyone, and thank you so much for joining us for the Connected Contracts Hackathon Workshop number 1. I'm going to go ahead and share my screen. And let's make sure that everyone can see. Awesome. So the DevPost Connected Contracts Hackathon is co-sponsored by the Moonbeam Foundation, by Axelar, and by Arrington Capital. This is a 6-week-long hackathon. It kicked off last week, and so it'll be wrapping up the last week of September. That may seem like a long way away, but it's actually, time is flying. So this is the second week. And so during the second week, we have a couple of workshops, which we hope you'll enjoy. So the introductory workshop we hosted last Thursday, that was with Axelar and Arrington and the Moonbeam Foundation. We discussed the logistics of the hackathon, and we spoke about the bounties and why we're excited to participate and to host this hackathon. So today, we're going to be talking about a lot of things. So first of all, what are connected contracts, right? Why are we so excited about connected contracts? And we'll also do 2 different hands-on demos with 2 different types of ways that you might start building your connected contract. And one of those is through XCM. And another one of those is through general message passing with Axelar. So the first demo that we'll do is showing general message passing with Axelar. We'll send a message to another chain on a testnet. And that'll give you an idea of how Axelar works, and it'll warm you up for Axelar's workshop, which is actually tomorrow. So tomorrow, they'll go into much more detail on how Axelar works and how you can build a cross-chain dApp that uses general message passing with Axelar. But today, I wanted to introduce you to the concept of connected contracts, kind of talk about why we're so excited about them, and then get into a little bit of the hands-on as how you can get started with XCM and with Axelar's GMP. So as always, you can always ask any sort of questions. You can put them in the Ask a Question box, or you can just add them in the chat and I'll see them there. I might not address them right away. I might wait until about halfway through or a quick pause. But rest assured that I do see them, and we will get to those questions. So in terms of the agenda, we'll look at it, an overview of connected contracts, and then we'll get into sending a message to a remote chain with Axelar. That'll be sending a message from Moonbase Alpha to a number of other different Ethereum-compatible chains. And then we'll also test out remote execution with XCM. So remote execution meaning we'll take an action on a remote chain. So from Moonbase Alpha, we will direct Moonbase Relay Chain, which is equivalent to Polkadot or Kusama. So it's a it's a relay chain structured exactly like Polkadot or Kusama. So we'll actually take an action on that chain, which is quite cool. It's a simple example, but it's extremely powerful because it shows you that you can enact a transaction that's happening on a completely different chain. And we'll also walk through the permissions of how that occurs. So first, this introduction is on an introduction to connected contracts. So before we talk about connected contracts, I want to take a step back and ponder the question, why is the future multi-chain? Work on Polkadot started back in about 2016. And Gavin Wood, Robert Habermeyer, and Peter Zabin, the 3 founders of Polkadot, took the idea early on that the future is going to be multi-chain. Now, today, that's not a controversial opinion. You say the future is multi-chain, and it's a common belief. But back in 2016, it actually was a controversial opinion, and it was not popular. Back in 2016, the prevailing opinion was that one smart contract platform, perhaps Ethereum, perhaps another one, was going to figure out how to quote scale or handle all of the world's needs for a blockchain, and that is a difficult and also it's not a very practical way. So Polkadot's founders took the belief early on that the future was going to be multi-chain, and that has directed the architecture of Polkadot from the early days. And so when you have that realization, that allows you to focus on connecting blockchains. It allows you to focus on, okay, so we know the future is multi-chain. So how are we going to build to enable that multi-chain future? And so what I'm hinting at is that Polkadot has had this advantage for a long time. And if we look at, okay, why is the future multi-chain? Exactly. And how has this vision evolved? Well, one of the reasons is that there are an increasing number of assets and an increasing number of users. And when you have all these new users coming in, they're trying out different games, different applications, different use cases. And many of these use cases drive demand, for new chains. And with an influx of new users, right, we need to have new, essentially scaling options for these new users. And part of that includes new chains. Another reason is that frameworks like Substrate allow you to build a new blockchain relatively easily. So you can launch your own Substrate-based chain on a testnet in about 5 minutes. It takes a lot longer if you are setting up a Substrate-based chain in production in real life, because you have to win a parachain auction and you have to go through token economic considerations and the like. But the point is that the number of chains is constantly growing, and it's not slowing down anytime soon. This is absolutely going to continue to increase as time marches on. And another one is that chains are becoming increasingly specialized. So whether your use case is gaming, whether it's cross-border settlements, or whether it's specific functions, you're going to have different demands for your chain. So for a gaming-based chain, you might have very quick throughput, and you might have constant interactions with the blockchain to facilitate a smooth experience in your game. And what you might end up with is something that looks a lot like a layer 2, like Boba. Whereas if you were doing something where you're managing billions of dollars on a regular basis, then you might end up with a blockchain that looks a bit more like Bitcoin. And so as we have this increasing chain specialization, right, we need to find a way to connect all of these blockchains together. And that's kind of the idea that Polkadot took early on. And Polkadot enabled this vision by building a relay chain to connect all these different blockchains together. And the relay chain is a layer 0. You're not going to launch an application directly on a layer 0, but you can launch a blockchain on a layer 0. And Polkadot handles all the security, the governance, and the coordination. So the coordination in determining who can run a parachain on the relay chain, and how are we going to connect all of these together. So Polkadot handles all of that, and it makes it a very powerful place to be for interoperability. And it allows for increasing chain specialization. So where Moonbeam fits in is Moonbeam is a hub for connected contracts. It's a place where you can access all the different parachains that are deployed to the Polkadot ecosystem. And these parachains specialize in different things, whether that's connected contracts on Moonbeam, whether that's privacy, whether that's decentralized identity, whether that's stablecoins. So all these other options, exist in the Polkadot ecosystem, and Moonbeam provides a native way for you to connect to these other chains and to take advantage of the functionality that they have natively on these other chains. So not only that, we're very focused on connecting to ecosystems outside of Polkadot as well. So that includes environments like Ethereum, Cosmos, Avalanche, and more. These are just a subset of the chains. And this is enabled in part by Axelar's general message passing, as well as Layer 0's technology, which is similar. We'll talk more about exact use cases and exactly how this breaks down, but envision that we want you to be able to access any contract on any chain. So you don't have to worry about bridging funds to another chain, or about having to get the native token of another chain and perform a complicated series of maneuvers. We want you to be able to access any contract on any chain, all from Moonbeam. And how do we support the structure of connected contracts in general? Well, a major component is that Moonbeam provides the ideal developer environment for Ethereum devs. So early on, Moonbeam made the engineering decisions to be as seamlessly Ethereum compatible as possible. And there are a number of things that enable this, including Frontier, including a unified account structure. So you don't have to maintain a Polkadot account and an Ethereum account. You can do everything from a single Ethereum account and a single Ethereum private key. So we're very focused on the developer and the end user, so that your experience as an end user and as a developer is very familiar, if not better. And so it's not only that, but it's the ability for you to grow and scale your project as your project grows. So you might launch as an application on Moonbeam, and you might decide at some point that you are big enough for your own parachain. And you can certainly grow into your own parachain, and you can connect natively with Moonbeam via XCM. So your users can still connect and interoperate with all of this functionality, even as you grow into your own parachain. You're not becoming some distinct island where nobody can access you anymore. It's just a different way of accessing the same functionality, which is very, very cool. So in order to understand, where we are and where we're going, it helps to kind of take a step back and look at, what are the multi-chain deployment strategies, of the past, right? If we want to see where we're going, it helps to recall, where we've been. And so there are two main ones of kind of multi-chain approaches that are the big ones, of the past. And one of those is a centralized deployment. And a centralized deployment meaning you pick one chain, you deploy to it, and then you say to all your users, you say, we're here, come find us here. You may have to bridge, you may have to get a new token to be able to participate. However, from a simplicity point of view, this is relatively simple, right? You have one deployment to maintain. The issue, you might see, one of the issues is that you're limiting your potential user base. So you're only deployed to one chain, and you're also potentially asking your users a lot, potentially, depending upon where they're located originally. You're asking them, they might have to bridge in, and so that's not ideal. And the second one is a multi-instance deployment. And Derek Yu, the founder, refers to a multi-instance deployment as a deployment where you're deployed to multiple different chains. You're taking your same project and you're deploying to many different chains. Now, there may be features that are unique to each chain, but in general, your applications are going to look familiar. And I also want to point out that you may interact with these different deployments from the same website, right? So you might be on the same page and you might say, okay, I'm going to switch my network. I'm going to switch from this chain to another chain. Then you switch your network in MetaMask or whichever wallet you're using. And so this was a good temporary solution, right? We want to expand the amount of users that we have. We want to meet them on any chain on which they're on. And it was a good temporary and solution for growing projects, right? But when we think about the drawbacks, right, you're fragmenting your users, you're fragmenting your liquidity and your features. And even though you might be able to access them from the same website, make no mistake, these chains and deployments, they don't know about each other. So they can't unify liquidity, or they can't unify a set of users across these different chains. They're very distinct and separate entities. And so this is really not ideal. And this is why we need a connected contract approach. And this connected contract approach is enabled by general message passing. So you may have heard of Polkadot's XCM, which is a general message passing protocol specific to Polkadot. It's not meant to be exclusively used within Polkadot. It's designed to be able to be adopted by other chains, but we're seeing, the majority of adoption of XCM within Polkadot. And so this enables you to do things like send a message to another chain and call a contract on another chain. So this is very powerful. And Of course, it also enables things like bridging assets and enacting actions on remote chains. So when we think of this, transferring value or transferring assets, is a subset of the things that you can do with general message passing. And one of the first use cases or examples that I want to share that's very, very powerful is Lido's Liquid DOT and Liquid Kusama contracts. So for Lido's Liquid DOT product on Moonbeam, they have a series of contracts on Moonbeam which enable you to stake your DOT in these contracts. And then these contracts will remotely stake native DOT on the relay chain. So think about this for a sec. You are enacting an action, a staking action on the Polkadot relay chain from Moonbeam, which is very powerful. So you don't need to worry about a Polkadot account. You may not even have a Polkadot account. That's perfectly fine. You can do all of this with an Ethereum-style Moonbeam account, and you may not ever touch the relay chain. But these actions are taking place and are directed from Moonbeam, and they're taking place on a remote chain, which is really, really cool. So this is one example of things that you can do via XCM. And it's one of the first, major ones, but it's certainly not, the only example. The next major example that I want to give is not XCM focused, but actually general message passing focused. And there's a protocol in development called Prime Protocol, and Prime Protocol is becoming a DeFi prime broker or a DeFi prime brokerage. Now, a prime broker in traditional finance essentially is a bundled set of services for some of the bank's VIP clients. And what this means is that the bank would be managing loans and lending for their VIP clients. And they typically manage a lot of the assets of these VIP clients. So if you're a VIP client, you might have stocks, you might have bonds, you might have things like houses as well with the prime broker. And so if you call up the prime broker and you say, hey, I would like a loan to purchase some stock, then the prime broker will look at all of your collateral and they'll say, you have plenty of collateral here, no problem, I can give you that loan. But in traditional DeFi protocols, a traditional DeFi protocol can only consider your collateral on a single chain. So if you want to take a loan out, let's say you want to borrow USDC on Moonbeam, and you want to deposit Ethereum as collateral. Typically, you need to bridge your Ethereum, and then you would need to borrow this USDC. And due to Oracle limitations and things like that, the number of assets that can be considered as collateral is limited. But with Prime Protocol wants to consider your assets across many different chains without having to bridge these funds. So Prime Protocol can have a home base or the brains of the smart contract being deployed on Moonbeam, and then it can have satellite deployments on these remote chains. And these satellite deployments can accept deposits of collateral. So if you had native Ethereum on the Ethereum network, you can transfer it to a satellite contract of Prime Protocol, and then Prime Protocol can consider this as your collateral for taking out a loan on Moonbeam. And so you can do this across many different chains. And not only is this safer, but it's also cheaper for the borrower. So what do I mean safer? Well, I mean, when you have a variety of different collateral, you're much less likely to be affected by price fluctuations or at risk of quick liquidation. And so it's safer for a borrower. And likewise, for a lender, if you have a safer borrower, you can give them a better interest rate. So you can give a cheaper rate to that borrower, so it saves them money. So this is a practical, hands-on use case, and we're very excited to see Prime Protocol get built out. And I'll share more, about this whenever we can. So to sum it up, the benefits of this connected contract approach include, one, solving fragmentation issues across various different chains. Overall, the goal of connected contracts is to simplify user experiences. Users might not be concerned with the exact contract that they're interacting with and the specifics about which chain it's on. They want to have an excellent user experience, as well as a secure and decentralized experience as well. And so this is what the connected contracts approach enables. It allows you to interact with any contract on any supported chain, and it allows you to provide better and more featureful user experiences to your users. So you're providing more features, you're providing more functionality, because you're linking together features that exist across many different chains. They don't need to leave and bridge to another chain. They can do it all from Moonbeam. And this is a general user experience improvement as well, because it's hiding this infrastructural complexity of which chain each particular contract exists on. So this is a very, very powerful approach to building an application. And so to wrap up with my introduction here to Connected Contracts, I just wanted to recap and show you that Moonbeam exists to access functionality across all these different Polkadot parachains, but also to connect with outside ecosystems like Ethereum, like Cosmos, and like Avalanche. And so the way that Moonbeam connects to Ethereum, Cosmos, Avalanche, and other ecosystems is through GMP, or general message passing, with Axelar and Layer 0, to name a couple examples. And to get a little more specific about how GMP works, this is a bit of a simplified example. However, you can see how powerful this is. For one, you can call a contract on a remote chain by specifying as little as 3 things. In practice, it might be a few more, because you'll want to have like a fee refund and a couple more parameters potentially. But it could be as simple as just saying, we're going to call a contract on X destination chain. So Ethereum, Avalanche, etc. We're going to call a particular destination contract address. So what's the contract address on that destination chain? And then 3, we're going to provide a message payload. And the message payload could be, in our example, we're going to send a simple message that says hello world, but it could be a more complicated contract call, and you need to provide the parameters or the input data that you'd like to provide to this particular contract. And that could tell it things to do. Maybe make a swap, maybe ask for an Oracle price feed. It could do all sorts of different things, all from a remote chain. Now, Axelar has their workshop tomorrow, and so they'll explain exactly what Axelar is, but I like thinking of Axelar as a universal overlay network. So instead of thinking as a layer 1, think of it as a layer that goes over existing blockchains and securely allows you to connect and to relay messages to these chains. One example of a use case of GMP would be to dispatch a governance decision from a chain to another remote chain. So as an example, you might have a DeFi protocol that launched first on Ethereum, and perhaps its governance is centralized on Ethereum. But that protocol has taken a multi-instance approach, and they have many different deployments across many different chains. But their governance is taking place on Ethereum. So how do they get their governance decisions to transfer out to these remote chains? Do they have to trust a single person or a single contract? Do they have to verify or validate that something is going to be deployed to that? Or can they do it in a trustless manner via GMP by dispatching a decision that takes place autonomously? So the dispatching of a governance decision to happen autonomously, that sounds a lot more desirable. And so that's one of the things that you could consider with GMP. So I want to get into an example of exactly how we can send a message to a remote chain. And we're going to do this with an example that was written by Jeremy from the developer relations team. And I'm going to go ahead and share this link here in the chat if you'd like to follow along. And I also want to make sure that I am zoomed in here enough so that everybody can see. Can everybody see my screen okay? That looks good. Okay, so we're going to be sending a message today from Moonbase Alpha to another chain. This will be taking place all across testnets. But one thing to keep in mind is that Axelar refers to the chain names by all of their mainnet names. So even if you want to send a message on a testnet environment, you do need to specify Moonbeam or Avalanche, or you need to specify Ethereum. You don't want to specify the name of the testnet like Robston or something like that, because in that case, it would fail. So we're going to be following along with this post. And what we're going to be doing is, again, sending a message. So the first thing that we'll do is we want to go ahead and open up Remix. So I'll open up remix.ethereum.org. And we're going to look at a particular, here we go, the GitHub gist here is a simple general message.sol. And this is a contract that we're going to deploy. Now, there are many instances of it already deployed, but we want to go through the steps of deploying this and then interacting with it. So I'll go ahead and paste this link here for ease of access for anybody who's following along. But I'll go into Remix, and I'm going to create a file named simple general message.sol. And I already have it here, but we'll just copy and paste so everybody knows that it's the same one. So let's copy and paste this. And we'll go ahead and compile it. And in the meantime, we'll make sure that we're on the Moonbase Alpha testnet, which we are. And so we'll head over to deploy and run. We're going to change our environment to injected provider MetaMask. And you'll see custom 1287 for Moonbase Alpha. So before we can deploy this simple general message contract, there are two parameters that we need to provide. The first one is an iAxelar gateway address. And the second one is an iAxelar gas service. These are critical, and you won't be able to interact without providing these two addresses. So the first one you need is the gateway address. So let's go ahead and copy that. And the second one that we need is the gas service address. So we'll go ahead and press transact. And I'll confirm the transaction in MetaMask. You won't be able to see the MetaMask pop up, but I'm just confirming a contract deployment. And shortly, it'll pop up and we'll be able to interact with it. If you don't have testnet funds, you can get those from the Moonbase Alpha faucet. So I'll go ahead and open that up. This is new. Previously, we managed a Discord faucet, but now we have a web app faucet where there's no tweet, there's no Discord joining. You just have to paste in your address and press submit. So it's very easy to use. Let's see if our transaction was confirmed, and it was. And let's take a look at all the different methods that we can interact with. So the one that we're going to be most interested in is send message. And it is a red button here to indicate that it is a payable function. We can send value along with this. And in fact, we need to send value along with this because we're going to be taking an action on a remote chain. And this is not free. There are execution costs that need to be paid for. And so when we send this message, we are going to be providing dev tokens along with this message, which will cover the execution on the destination chain. So we can send any sort of message that we'd like. I can say, hello, Connected Contracts Hackathon. Hello, Connected Contracts Hackathon, as an example. And we need to provide a destination address. And the destination address will be an instance of simple general message deployed on these remote chains. You can actually go through and deploy this yourself if you wanted to, but for ease of demo, we're going to refer to ones that are already deployed. So in this case, I will be sending a message to Avalanche Fuji testnet. And so I'm going to copy this address here. And we'll provide this as the destination address. And the destination chain will be Avalanche. Remember, we have to provide the name of the mainnet, not the name of the testnet. There's one more thing that we need to do before we press transact, and this is critical. And it's we need to send the appropriate amount of gas. Now, because each chain uses different units, we have specifically mentioned the amount of whey that you need to provide. So we will go ahead and copy the respective amount of whey, and we'll paste that in here. And once everything looks good, we'll go ahead and press transact. And we'll confirm the transaction in MetaMask. Just a simple confirmation in MetaMask, nothing that you're missing there. So we're doing great on time. We have plenty of time for questions. So if anybody has any questions, feel free to ask in the chat. Let's see how our transaction is doing. Awesome. So it's confirmed on Moonbase Alpha. We'll go ahead and open this up, and we will get a transaction hash here. So next thing I'm going to do is I'm going to go to testnet.axelarscan.io, and this will allow me to track the status of the transaction that we have sent, of the message that we sent from Moonbase Alpha to Avalanche testnet. So you can paste the transaction hash that you get from the origin chain. You can also pass in a handful of other bits of information, but we'll be looking by transaction hash on the origin chain. Okay, so we can see a lot of information here. We can see that the contract call was successful on Moonbase Alpha. The gas was paid on Moonbase Alpha. And very shortly, this should be taking, this message should be delivered onto Avalanche, the Avalanche testnet. So what we'll do real quickly is I just want to show you the payload details of this original transaction here on Moonbase Alpha. So we see some input data, quite a lot of it actually, but let's go ahead and change view input, and we'll change it to UTF-8. And you can see here that we have our message. We have hello Connected Contracts Hackathon. We can also see that we have an address here, and this address is the address of this simple general message on Avalanche testnet. So that was the second parameter that we provided. And then the third one is the name of the network. So those are the three parameters that we provided when we were sending our message. So we see that the call was approved, and it should be executed momentarily. We'll come back to it in just a second. But I do want to take a quick pause and see if anybody has any questions. Cool. So we will check back on this. Okay, here we go. So it was executed. And time spent, 2 minutes, 20 seconds. And let's go ahead and look at the transaction hash on the destination chain. So we can see here that the interaction was successful. And we can see here exactly the function that's taking place. We see execute and source chain, and we see all this sorts of information, including our payload here. So that's all I wanted to demonstrate for this example. But we do have a very interesting XCM example as well, which the complexity of which is a bit more involved. So this is a great place, to pause if there are any questions. Okay, cool. I see one. What happens if the gas we send is not enough? Socrates, that's a great question. The transaction would fail, and we can actually try that and see what would happen if we sent less than the specified amount. I believe that it might fail in progress. So it might be accepted and then it might fail once it's already in progress. So let's try that. Okay, where were we? Okay, way. And I'm going to take off some of the way, so it's not nearly enough. And we're going to send the same thing. Everything else is staying the same. It is accepted. Yeah. So you can see we're sending in the MetaMask pop-up. I should clarify. The first MetaMask one provided 0.09 dev, and the second one here in this pop-up is 0.0000264 dev. So we're sending along significantly less dev tokens. But the transaction is still going through on the origin side, and it will most likely fail while it's in progress. So we'd get to a point here where it would get to somewhere in the status flow, and it would fail. So I will check back in on this transaction in just a couple minutes. Maybe we can see exactly what happened. That's a great question, Socrates. Thank you so much for asking. So let's do a little bit of XCM prep right now. We still have about 25 minutes left. So what is XCM? I want to do a quick introduction for users who are new to XCM. And if you're very familiar with XCM and you have any questions about it, by all means, drop them in the chat. So XCM is just you can think of it as a language. It's a way for blockchains to communicate with one another. And that's right, I mentioned blockchains. I didn't say Polkadot parachains, because XCM is meant for different blockchains to be able to talk to one another, and it doesn't have to be specifically on Polkadot. It's a very generic format, so it doesn't assume a lot. You have to be very pedantic and specific about what you want to do. So if you're making, let's say, you're transferring value from chain to chain, there are a lot of things that you need to specify, quite a lot if you're constructing the message manually. But most of the time, unless you're a very low-level blockchain developer, you're not going to be constructing the message manually. Instead, you'll be relying on things like a precompile, such as xtokens.sol or xcmtransactor.sol, where you'll specify a variety of parameters, but it's a lot easier than constructing the message manually. One of the huge perks of this is that XCM is forwards and backwards compatible. That means that all the different parachains that are using it don't need to upgrade their runtime at the same time. You can imagine how chaotic it would be if Parity one Sunday, at 2 a.m. said, "We've got an emergency release. Everybody needs to upgrade their their runtime." Parachain teams are around the world. It's in many different time zones. It's not practical to be able to coordinate all of these at once. So what that means is that with versioned XCM, your parachain can be compatible with a parachain that's on a newer version or an older version, and you can rest assured that your messages are going to be interpreted and processed correctly. That doesn't mean that every feature is going to be available to every chain, because if a new version of XCM is released and that features a new feature that hadn't existed before, and there's a certain parachain that doesn't, implement that new version of XCM, then that wouldn't be compatible. But it's not going to break XCM. That's important. It's not going to create a situation where you send a message and then it's going to completely go haywire and cause some sort of issue. It will still be interpreted and processed, which is very, very important. So before you can send an XCM message, you have to have a channel that's set up. And channels are opt-in, with the exception of channels that are established automatically between each parachain and the relay chain. So by launching as a parachain, you already have two connections. You have a connection to the relay chain, and you have a connection from the relay chain to you. So XCM channels are one way. So if you want to have back and forth communication, you do need to have two channels. And the example that I just described was vertical message passing, communication between the Polkadot relay chain and a parachain. But the example on the right we have is cross-chain message passing, which currently cross-chain message passing refers to parachain to parachain communication. And currently all this goes through the Polkadot relay chain. But in the future, it'll be directly parachain to parachain. So it's just one hop. And that will also increase efficiency so that these messages don't have to slow down the relay chain with this overhead. So that's very, very cool. And I wanted to show a quick example of what XCM enables. And this is really the first use case when XCM was first production ready, was transferring assets between different chains. As an end user, you're going to be interacting with a wallet, or an end user would be interacting with apps.moonbeam.network. As a developer, it's helpful to understand what's going on under the hood. So let's say that Alice wants to transfer DOT from the relay chain to Moonbeam. What's going on under the hood is that those dots from Alice's account are first being transferred on the relay chain from her account to Moonbeam's sovereign account. And then the Moonbeam sovereign account has those native DOT tokens deposited, and then a derivative XC dot is minted on Moonbeam. And then this XC dot can be used within DeFi. It can be used in a variety of different things, and that's very powerful as an XC20. And an XC20 is a substrate native asset that is fully compatible with the ERC20 interface. So anything that you can do with an ERC20, you can do with an XC20. That includes DeFi, that includes yield farming, that includes staking, all these different type of interactions that you want to do. You can do that natively with an XC20. And if you wanted to go back from a parachain to the relay chain, you would programmatically, those XC dots would be burned, and then the Moonbeam sovereign account would release those tokens. And you don't have to be the original, transferer to get back those tokens. You could just acquire some XC dot on Moonbeam in the first place, and then you can just transfer those back to DOT if you wanted to. There's no need for you to be like the original, person that transferred those over. Let's take a quick look at our transaction where we were providing less gas. So if you don't mind changing gears with me for just a second, our transaction was confirmed here on Moonbase Alpha. I'm going to copy the transaction hash, and I'm going to look it up in Axelar scan. See the status. Moment of truth. Okay, so we got through a couple different steps. We failed at the execution step on the destination chain. And the exact error here was not enough gas. So there you have it. And there we go. Let's head back to the XCM examples. I'm going to quickly, I want to take a quick, I want to head to the example because I want to make sure that we have enough time for the example. But the example that I want to show is an example of remote execution. So that's taking an action on a remote chain. let's do a quick little bit of setup. So the first thing that I'm going to do is I want to open up my terminal, and I'm going to share a different window here. So let me first show you the repo that we'll be using, and that is XCM tools. So let me just see if I have that XCM tools. Here we go. So we're going to go ahead and clone this repo, and there's another one called Polka Tools. Let's go ahead and clone that one as well. So this is kind of the prep work, and I'm going to quickly stop sharing, and I'm going to share my terminal. Let me see if everybody can see. Okay, good. So we're going to go ahead and clone XCM tools. And let's also clone Polka tools. Let's go into XCM tools. And let's do one thing. First, we need to run yarn. Make sure that we have everything installed that we need. And I want to run a command called calculate sovereign address. So I'm going to say ts node calculate sovereign address, and I need to provide a parachain ID. So in the case of Moonbase Alpha, the parachain ID for Moonbase Alpha is 1000. And we also need to specify the relay chain that we'd like. So we'll say Moonbase here. So what we're doing here is we are getting the sovereign account address of Moonbase Alpha on the Moonbase relay chain. So see here this long address. It doesn't look like a Polkadot format. We can convert it into the typical Polkadot format via a tool like Sean Tabrizi's Polkadot tools repo. But the next thing that I want to do quickly is I want to take this information that we just got here, and I want to go to, so let's go ahead and copy this address. And I want to go to Polka tools. And we have to run yarn again, make sure we have everything that we need installed. And then I want to run ts node. I want to say calculate derived address. Now, quick pause. Why do we need a derived address? What are we doing here? We're going to be performing an action on a remote chain, and we need to have a bit of a privileged account in order to do that. And the way that that's taking place is we have a special account that's registered to have privileges to be able to enact this transaction. So this registration process happens via governance. And so we have an Alice account, which you can see. I'm going to post the link here in the chat. So this is similar to a workshop that I did in Paris. Yes, this is being recorded. So all of this you can rewatch. So sorry for rushing. I just have about 15 minutes left, and I want to make sure that we cover everything that we'd like to cover. You can see a special private key on this page. So if you open it up, you'll see a special private key. And this Alice account has privileges to be able to execute dispatch a transaction on a remote chain. And this is a shared testnet account. Don't use it for any real purposes. Just use it for testing. So we have to provide a couple parameters for this. And if we want a reminder of what parameters we need to provide, you can use the help, or you can just try running it. So we need to provide the address here. So that's the one that we have from above. So let's copy this address. And then we also need to provide an index. So what is this index? Well, when we registered this Alice account, we registered it at a particular index. So that index in this case is 42. You can look that up on Polkadot.js apps very easily, which I'll show if we have time. So the next thing that I want to demonstrate is, let's go into the Polkadot relay chain, and I need to change my screen to here. And we need to go to Moonbase Relay. We also need to open up Moonbase Alpha. So I'm going to open up a few different tabs. And I also want to zoom in so that everybody can see. Okay, so we have a couple different accounts here. If you don't have one, just go ahead and create one. This is on Moonbase Relay, and this will work with your typical Polkadot account. So go ahead and create one if you don't already have one. What we're going to be doing is we're going to go to extrinsics. And you can see here, I've already imported this particular Alice account. So this is very important. You'll need to do this. I not only have Alice imported in Polkadot.js apps, but I also have Alice imported on my MetaMask. So that's an important step. Remember to clearly mark that account as being a special type of testnet account that everybody has. So we're on Moonbase Alpha, and we're going to be taking an action on the Moonbase relay chain. So we're going to be using the Alice account to interact with XCM Transactor. And the exact method that we want to use is transact through derivative. So we're transacting through derivative because we've registered this particular derivative account. And the parameters that we're going to provide is just relay here. And we're going to provide a particular index. That's that same number, the 42 that I specified before. Self-reserve is going to change to for an asset because we're going to be moving an asset on the Moonbase relay chain. That's the example that we're going to be demonstrating, is to transfer not from chain to chain, but we're going to tell Moonbase Alpha to, hey, I want you to make a transaction on Moonbase relay. So that's an important distinction, is we're not transferring assets cross-chain. We're telling another chain to send value from one account to another. And the account that these funds are coming from is this special derivative account, which I pointed out here. This is already funded, and we can actually check the balance of this account so that to kind of bring this all into context, because I want to make sure that everybody is following along and that I'm not jumping over things too quickly. So in system account, I'm going to paste in this derivative account, and let's see if it has a balance. It does. It's got a big balance. And so this has a balance of XC unit tokens, which is the native token of Moonbase Relay. And so we're going to be asking this account, which we have special permissions to do, we're going to be asking this account to send funds to another account that we choose. That's all we're going to be doing. And we're going to initiate it from Moonbase Alpha. So the asset that we want to transfer is XC unit, and I can get the asset ID here from the Assets tab. I'm going to open it up in a new tab so that we don't lose our work that we put in so far. And one thing that you notice here is that there's a lot of commas here. And Polkadot.js is not going to accept that if it has all these commas. So you need to go through and just remove all the commas. There might be better ways of doing this, but for a quick demo and for simplicity, we're just going to remove them one by one. And we're going to come back here, and we're going to provide this as the asset ID here. Next thing that we're going to do is provide a destination weight. You can enter a billion, so 9 zeros is just fine. And lastly, we need an inner call. And the inner call tells you exactly what transaction that you want to take. And the transaction that we'd like to take is to transfer value. So how do I get the bytes for this particular transaction that we'd like to make? We're going to simulate a transaction. We're not actually going to take it, but we're going to simulate what would happen here. So let me head up let me get rid of this include option. Let me go to extrinsics. So that's important. You need to go to extrinsics. Selected account here does not matter. It only matters the account where you're going to be sending to. So we want to go up to our balances palette and want to select transfer. I know I'm moving quickly. I'm sorry. We just have five minutes left. So we're going to pick an account here that we'd like to transfer to. So I have this account called Polkadot NYC. I'd like to transfer to that one because it is currently empty, and we'll be able to see when the funds arrive at it. And we want to send just one XC unit, and we need to provide 12 zeros here. So 1, 2, 3. We're not going to send the transaction here. All we're going to be doing is copying this encoded call data, which tells us the transaction that we want to take place. Okay. So we're going to provide this here. Now, very, very important. Don't copy the encoded call hash, copy the encoded call data. So let's go ahead and submit this. Everything looks good here. Again, we have to be using the Alice account. If you try any random account, this will not go through because it will not have the permissions to execute. So let's go ahead and submit the transaction. If everything goes correctly, we should see a balance of 1 XC unit transferred from this derivative account to that Polkadot NYC account that had a balance of 0 XC unit. Okay, so the transaction was successful, and let's see if the balance increased, and it did. It increased by 1, as we expected. So this was a simple example, but it showcases the power of XCM and the power of what you can do with this connected contracts approach and with the power of XCM Transactor. Now, it's not limited to just sending funds on a different chain. You can do things like Lido does, which is you can execute staking operations. There is another upgrade in the works where you'll be able to make a remote call from another parachain into Moonbeam's EVM. And so these are the types of things, which truly enable a connected ecosystem for connected contracts. And so different parachains and Moonbeam itself is not an island. You're not trapped on one chain, but you're able to interact with these other chains natively. And as a developer, you can build use cases, and you can build, you can hide complexity, right, of this cross-chain interaction, right? You can hide this complexity, and you can make it so that the user doesn't particularly have to know all the steps of how this call is working via XCM or via GMP. You can hide this complexity, and you can provide a better user experience and provide them access to more features. I know this was a very quick demo, and is there an example link tutorial where XCM, where we can call a function on a smart contract deployed on Moonbase Alpha? That's a great question. So right now, you would be able to use GMP. You'd be able to follow Jeremy's example, which was here, and you can change around the parameters. So you could start from another chain, and then you can call into, you could choose Moonbeam as the destination chain, and you can send a message. In this hello world example, when you send a message, you could also call a contract as well. That's for GMP. For XCM, remote calling a function in Moonbeam's EVM via XCM, that's not yet documented, and it's not yet fully finalized. So that'll probably be coming soon, and that'll be really exciting to share when we have all of that there. So I think these are great questions. Thank you so much, everyone. And yes, this is being recorded. It'll be here on Crowdcast. It'll be available on YouTube. I want to thank everyone so much for joining us. And the site that I want to highlight here is moonbeam.devpost.com. So this is the hackathon website. You can get registered here. You can see all the different bounties and descriptions and everything like that. So I highly recommend that you check this out. And we can't wait to see what you build. So be sure to reach out in the Discord, discord.gg/moonbeam. Let us know if you have any questions. We're more than happy to have a discussion there. And thank you so much for joining us this morning. Look forward to seeing you in the next workshop. So the next workshop is with Axelar. That is tomorrow. That's Wednesday, and it's the same start time as this workshop today. So thank you so much, and I look forward to seeing you in the next one.